Hey everyone, in this video we're going to talk about section 1.3, which is about classifying angles. Prior to watching this video, you should have taken all of these vocab words and written them in your glossary. Knowing how to define these words is going to be really important before we go through these examples. So if you haven't done that already, go ahead, pause this video, go back and do that, and then come back. All right, so we're going to be looking at this diagram here, at least for the first example, and we're going to use this to identify a variety of different angles. The first one that we are going to look at is complementary angles. So remember, complementary angles are angles that add to 90 degrees. Okay, so what we're looking for is we're looking for some numbers or some measures that are going to do that. Okay, so one thing just to note here is that this is a 90-degree angle. That's great, but that doesn't make it complementary because I need two angles that are going to add to 90 degrees. So I see here I have a 27-degree angle and a 63-degree angle, and 27 plus 63 is 90. So I'm going to use those. Now, for this diagram, if you remember, when angles share a vertex, they all share that vertex point O. I can't use just the vertex to name them because every angle would be O then. So we have to be more specific. So we have to use our three letters. So if I'm going to name this angle, I might name this angle BOC with that vertex in the middle. Okay, I could have also gone COB, and that would have been the exact same thing. Okay, but I have BOC, and this angle here, let's call that COD. Okay, notice I'm also naming angles, and so I am writing the angle symbol out in front of them. Okay, the directions don't really tell us how many angles to name, but I do think it's worth noting that complementary angles just have to be two angles that add to 90. They don't have to be next to each other, so they could also be non-adjacent. So for instance, I could have that 27 and maybe I pick this 63. Okay, that still meets the qualifications for complementary angles. So I'm going to add that in here. So I'm going to say, or, let's see, we still have angle BOC. But now we have angle AOE. All right. Okay, next up, I'm going to clean up our diagram here. Next up, we have supplementary angles. So remember, supplementary angles are going to be two angles that add to 180 degrees. Okay, so I'm looking for measures that are going to do that. Let's see. I have a 63-degree angle here and a 117-degree angle here. And 63 plus 117 is 180, so I can use these. So I'm going to have angle, let's see, we have COD again. And now I have angle DOE. Okay, I want to point out that sometimes with our angles, while we can see a variety of different ones, we also can define angles by just looking at our 3 points. So for instance, I know that I have this ray OC here, but I could also focus just on my angle that is made by BOD. Okay, so that would be just looking at that larger angle, not seeing where that ray divides it into two parts. And so if I were to do that, we decided already that 27 plus 63 together made 90 degrees. So another way that I could define supplementary angles is I could look at this angle, which I know to be 90 because of that box, okay? But I could also look at the BOD angle because that larger angle without that ray in the middle is also 90. So I'm also going to say here for supplementary that I could also define angle AOB and angle BOD as supplementary too, because those two angles do add to 180. Okay. Our next word is a linear pair. And if you remember, a linear pair is going to take kind of two of our words and put it together. So linear pairs have to be supplementary, but they also have to be adjacent. Okay, remember that adjacent means that they have to be next to each other. Okay, they have to share a ray or a segment. So it looks like we've already actually defined that. Angle COD and DOE were a linear pair because they added to 180, but they also shared that OD side. So COD and angle DOE are a linear pair. Okay, you should be able to see some other linear pairs in there as well, but that's at least one example of it. Let's clean this up. Okay, next thing we're looking for is vertical angles. So remember, vertical angles are going to be two angles that basically are across from each other when two lines cross. Okay, vertical angles also, we can picture those, or at least what do I want to say? Identify those, because they're going to have congruent measures. So here I see a 63 and a 63, so those are going to be my congruent angles. Okay, so I can name angle AOE and angle COD as vertical. Okay, there's some other vertical angles in here, but that's at least one example. All right, adjacent angles. We know that adjacent angles are going to be angles that are next to each other. Okay, and because we've already named a linear pair which had to be adjacent, that means that we have those adjacent angles. However, let's look for another two that are adjacent, maybe something that we haven't named before. Let's see, we have angle AOB, okay, that's that 90-degree angle, but BOC is also adjacent to it. So adjacent angles don't need to add up to anything specific. There's nothing specific about their measures, it's just about their location. So I'm going to have angle AOB and angle BOC. Okay, our last word that we're looking at is non-adjacent, and so that is the opposite of adjacent, and if you're thinking not next to each other, you are exactly right. Okay, so non-adjacent angles just can't share any larger part than just a point. Okay, so they can share that vertex point, they just can't be right next to each other. So maybe we look at angle AOB and angle COD. Okay, those angles do not share a side because I have this BOC in the middle that's kind of preventing them from being next to each other. All right, our last example that we're going to look at in this video is going to be to find the measure of each angle indicated in this diagram. Okay, so we have a bunch of lines, 3 lines that are crossing each other. We are trying to find this angle here and this angle here. So one thing that I always like to look for as much as possible is I like to look for my vertical angles, because I know vertical angles are going to have that same measure. So I know, for instance, that if this is a 45-degree angle here, the angle that is across from it, okay, that's formed by the same 2 lines that are crossing, will also have the same measure. So that means that this angle here is 45 degrees. Okay, if I wanted to use that same principle to find my other missing angle, I see that scale at least isn't going to work for us because, well, across from that other question mark is nothing. Okay, we don't actually have a measure there, so we're going to have to use something else. So what could we use? Well, we can use the fact that angles that form a straight line should add to 180. Okay, we know that angles in a full circle add to 360, so half of 360 would be 180, and that just means that we've gone in a line. Okay, we haven't gone the full circle, you've gone halfway, that makes a line. So I can see here that I have 2 of the 3 angles that form this line. Okay, I have the 45, I have the 64. Okay, we're just missing what this middle portion is. So because of that, I know that these 3 angles all together should make 180. So 45 plus something plus 64 makes 180. So we should be able to just subtract 45 and 64 from 180, and we're going to find what that missing angle is. So if we do that, and I'm going to encourage you to pull out your calculator just so you can double check me. If we do that, I personally got that we get 71 degrees. Okay, if I got something different, let me know. We can change the video or make a disclaimer, but 71 degrees is what I got. All right, okay, that's all that I have for this video. Your next task is going to be to try out those check your understanding questions on the next page. So I will see you all later.